Eric Darling here with Darling Data, voted by Beer Gut Magazine to be the producer of the freshest, hottest SQL Server content on the internet. So if you're into that sort of thing, well, you're in the right place. Welcome aboard. In this video, we're going to talk about a somewhat overlooked problem that you can run into with outdated statistics. Especially, well, I mean, I guess it could really apply to either cardinality estimation model, either what Microsoft quite smugly refers to as the default cardinality estimator, which is the one that you use if you're in a compat level higher than 120, which is around SQL Server 2014, or the legacy cardinality estimator. Again, very smug nomenclature there. Which is the cardinality estimator that you use if you're in compat level 110 or lower, or you have the database scoped option database scope configuration option to use the legacy cardinality estimator turned on, enabled. This thing is looking a little funny on me. It's looking a little too happy down there. One thing that a lot of people overlook. So, like when we think about outdated statistics. What a lot of people focus on is, that you have this 200-step histogram, and perhaps the values in the histogram don't reflect what like the actual counts of things that are in the table for like existing data, which is totally a reasonable thing to be worried about. This can happen either because let's see, let's think of some reasons here. Either you haven't updated stats in a while, and the numbers that are in the histogram just don't like a bunch of data got added, and the old histogram said that you had like 500 rows for this thing, but now you've got like 500,000 rows for this thing. Granted, that's a little far-fetched. If you have a big enough table that you could see that sort of difference. But auto stats will kick in eventually. And I know how wild you crazy kids are about rebuilding indexes, which will also update stats. But let's just say for a minute that you had some just wildly outdated stats that hadn't been updated in a while because you have a huge table. You haven't met the auto stats threshold yet. Auto update stats threshold yet, and you just had like wildly inaccurate numbers. That could also happen if you don't use a high enough sampling when you do a stats update. If you just use a default sampling, you can miss a whole lot of really interesting data points. And apparently I smoked too many cigarettes, or apparently since I don't do that, we're a family friendly, we're an addiction free channel here. We are only addicted to making SQL Server go faster. We don't smoke cigarettes. Though we do miss smoking cigarettes. One of the big things that I run into is that you've added like new data to a statistics histogram that just isn't reflected in it at all. A lot of people will call that something like the ascending key problem, which is a valid name for it. There's all sorts of writing about it, and it is something that can actually cause pretty severe performance issues, because depending on which cardinality estimator you're using, you could get some wildly different guesses depending on how many rows are in the table, and how many values match a certain predicate and all this other stuff. And you can end up with some really bad execution plans when you start joining those tables off to other tables, and the predicate estimates, like rows coming out of the table, don't really reflect reality, and so you don't get the join that you get is again not in line with reality, and you get like a nested loops join when you really shouldn't have. So we're not going to delve that far into it in this video. I'm just going to kind of show you what it'll look like when that sort of thing happens. So in my copy of the Stack Overflow database, what I've done is I've created a table called votes_beater, and we're going to beat this table up a little bit. I didn't want to do it to my actual copy of the votes table because I don't like messing with I don't like messing with them. Life is hard enough. without having to. Well, actually, I don't have ever have to restore a database if I do something like that. I keep a version of the Stack Overflow database that I do nothing in, called Stack Overflow Clean. So if I ever really mess something up in a table, I can just copy it from this other database. I'm a cheater like that. I don't like restoring databases. It's not my thing. So I've created an alternate table to use. And I've inserted all the data from the actual votes table into it. You can see I did all my homework there. And I created an index on it on the post ID column, because that's the column that we're going to focus on here. Now, at current, actually no, because I already did all this stuff. What this query returns is just some statistical information about what's in there. Now, right now, I have 229,561 modifications against this table. In order for auto update stats to kick in using the new auto update stats thresholds, the old auto update stats threshold was 20% of the table plus 500 rows, which is, let's just face it, 20% of the table. And it kills me when you have to stick to plus 500 rows. Because, yeah, it's still like still be close enough to 20%. If it's a table big enough for you to care about, 20% is 20%. Adding 500 isn't meaningful. And the current range high key in the statistics histogram is this. But there's a whole lot of data within these modifications that has a range high key for post ID higher than this, right? So that's the important thing here. So what I did in order to facilitate this nightmare is I created a temp table. Did some work to validate the post IDs that were going to be deleted. Deleted the top, and now so the stats modification counter that I just showed you here, that was about 500 rows higher, plus 500, right? 500 rows, who cares? Well, now we're going to talk about how much 500 rows makes a difference. So I subtract. So when the table was a full size, right, before I deleted rows out of it, there was the auto update stats threshold was 230,062. So I just subtracted 500 rows out of there, and so this number minus 501, and I deleted those rows out. And on the delete command, I outputted those columns into the votes temp table. Then one thing that I did that's really important before anything else was I re-updated statistics. Right, the stats update here is to prevent me going over that modification counter, because remember, deletes count as modifications. So I wanted to update stats to zero that out. And then I inserted all the rows from the temp table back into votes beater. And I did some work to find the highest post ID with more than one hit to it, or rather the post ID over that the stats high key, the range high key, and for this statistics object that had the most in there, right? So I want to show you how the guess is crappy. So with the legacy cardinality estimator, the problem that you run into is whether you have an inequality predicate or an equality predicate. SQL Server only ever guesses that one row is going to come out of there. And let me just scooch these dummies together a little bit. So for the inequality predicate, we get 229,877 rows back, but SQL Server only thinks that one row is going to come out of there. For the index seek, where we find 300 rows, SQL Server only guesses that one row is going to come out of there. This is a thing with the legacy CE that Microsoft has done did some work to improve upon, and has tweaked and mangled and done all sorts of things that have made it, it's still better, but it's the constant tweaking. It's like who can keep up, right? It's like every CU there's just some thing that's slightly different by like a percent. Nothing works anymore. Everything's broken. With the new cardinality what Microsoft so pompously calls the default CE, things look different. And what I'm going to show you here, I have this use hint, this enable hist amendment for ascending keys hint on this. And the reason I have this here is because SQL Server has not marked the post ID column as being ascending. I tried it with a few different columns in the table, including the creation date column. And SQL Server did not think that any of them were ascending. So we're just going to stick with post ID, and we're going to throw this hint on there to show you the difference. So if I throw this hint on this query, and we search for where post IDs are greater than what's in the current histogram, we get a guess, or rather we get an estimate that just about matches the modification counter in the table, right? So 229561. If we had 229562, AutoStats would have kicked in. So when we tell SQL Server that this is an ascending key and SQL Server runs this query, the cardinality estimation process looks at how many modifications there are and says, okay, well, maybe there's that many rows. This is for an inequality predicate. If we don't add that hint on, SQL Server guesses about 30% of the table will be in there. So this number changes from being the modification counter to about 30% of the modifications. Right, so 68868. I'll show you the math on that when we get through these demos, so you can be happy that you watch this. And when I say, I hope you learned something, you can say, oh, yeah, I did learn something. I learned some math. And then you're going to say, oh, I learned math from a high school dropout. Then you're going to say, maybe I shouldn't learn math from a high school dropout. We'll see. I don't know. So anyway, if we look at the equality predicate with the enable ascending key thing in there, we will get a guess of 55, or an estimate of 55 rows, right, out of the 294. So remember, with the default CE, those are both guesses of 1. So with the new cardinality estimator, you get slightly different guesses depending on, if SQL Server has marked the index or statistics objects being an ascending key, you wouldn't have to use these hints, but in my case, I'm using them to sort of fudge things a little bit. So what we get, if we look at the stats properties again, which will help explain those numbers a little bit. So for the ascending key inequality predicate, we got just basically the modification counter as a cardinality estimate. For the default CE without that on there, in order to get 68868, which is this one, we basically look at the modification counter times 0.3, so about 30% of the modifications. For the default CE cardinality estimate, you know what we get here? We actually get a density vector estimate. Now, if you're unfamiliar with the density vector estimate, that's something that comes from looking at the statistics object, which we're going to go do, right? We're going to go look at this, and we're going to go to the properties. And these two numbers here, if you've ever watched my videos or read my posts or read anyone's posts about local variables, you'll know that when you have an equality predicate with a local variable, absent or recompile hint, cardinality estimation changes from like a parameter sniffing thing or a literal value estimation thing to using some magic numbers. Those magic numbers come from the statistics object. If we go into the details here, let's just make this full screen to make it easy. If we look at the density of the column, of the post ID column, which is this, and the number of rows in the table, which is this, and we multiply this by this, we get that density vector guess. All density is just sort of like the assumed uniqueness of this column, so the SQL Server does some math in there to figure out how unique it thinks the post ID column is, which is again a total guess based on, like something times the distinct number of rows. So SQL Server comes up with this number and multiplies that density number by the rows number, and that's where we get that guess of 55 from. So that explains pretty much old versus new when it comes to outdated statistics, especially when those statistics don't have, like when the high key of those statistics don't have, it does not match what the current high value is in a table. It's a lot, maybe it's a little bit easier to think of in terms of like a date column or a date time column where, every row that gets added, it's almost like an identity column where every row that gets added is new. Right, it's a higher value than what was there before. It's it's sort of like an append only, type insert scenario. It's not like it's like an order date column, not a ship date column, where ship date comes in null and gets updated. Order dates are always going to be new. Every order is going to be newer than the order before it. So that's like an ascending key, same as an identity column in that regard. So really one of the biggest dangers that I can see, or rather one of the biggest performance landmines that I see a lot of people run into is when they don't update stats frequently enough, or if they just depend on autostats to do their thing, then they end up with these histograms that don't represent the newest data, right? It's not really about the data that's already in there most of the time. Most of the time, the data that's already in there is probably close enough to reality. You know, there are obvious exceptions to that, of course, you know, nothing is perfect, but it's usually the data that lives beyond whatever the current range high key is that messes things all up. Now, of course, if we ran a stats update on the votes beater table, we would have representation for those higher values in there, and we wouldn't have this anymore. So it's something you have to be really careful of, you know, especially if you're using the legacy cardinality estimator, which I often think is the much better cardinality estimator. Getting that one row guess can be an absolute disaster. So if you get that one row guess and SQL Server comes up with a, you know, crappy nested loops plan where, you know, you have lots and lots of rows but SQL Server's like, I think there's only one, you know, you could run into some real issues. The newer cardinality estimator does do better with this. You know, it at least gives you a guess of higher than one. It might not always be perfectly accurate, but often, you know, the fact that it's a bit closer to reality does buy you out of some, you know, potential performance landmines or pitfalls, potential performance pitfalls. Pleasant alliteration. Anyway, so you learned some math from a high school dropout. Hope you enjoyed yourselves. I hope you learned something other than math from a high school dropout. If you like this video, you can, you know, if you want to create a bunch of YouTube accounts to give extra thumbs up, you can do that. I'm not responsible for that voting ring, though. I would never encourage that behavior. I don't even thumbs up my own videos, which, I don't know, probably tells you something about what an ethical, honest person I am. If you like this sort of SQL Server content, please subscribe. Subscribers are awesome. I finally cracked 4,000, which means, in the grand scheme of things, probably not a lot. But if one of you lovely 4,000 or so people sees these videos and thinks, hey, we could use the kind of help that Eric Darling offers for SQL Server, you can hire me too. I am a consultant. I consult and I fix these problems and I find these problems and I analyze these problems and I guess actually no, I analyze these problems, find these problems, analyze these problems, and fix these problems. So it's the FAF method. It's the patented Darling data. Find it, analyze it, fix it. The FAF of SQL Server performance tuning. Don't steal that from me. I'll come find you, my Delta miles. And I think that's probably about good for today. I should probably eat something. I feel like perhaps my blood sugar is cratering a little bit. I think I'll go eat a beer or something. Maybe some chicken. Chicken's good, right? Chicken's healthy for you. I do apologize to if any of the data darlings out there are vegans. I do apologize. You can pretend I said something else, like tofurkey or some sort of bean. But anyway, I'm going to go do that, and apparently I have some drivers to install because Intel keeps yelling at me. So I'm going to do all sorts of fun things with beer and chicken and driver updates, and I'm sure you're going to be very jealous. I know that if I were not me, I would be very jealous. So as always, thank you for watching, and I will see you next time in another video. Hopefully there will be no math, because that's a promise I'd like to keep. All right. Thank you.